Hello everyone, welcome to yet another session in our PMP Refresher series on PMP YouTube channel. Session 2 is on creating schedule via network diagrams. Last week in session 1, we saw earned value management. So if you have not seen it, please visit that video on this channel. You can like, comment, share that video, and also subscribe to this channel. So without much ado, let's get into session 2, which is creating a schedule using network diagrams. To keep our discussion crisp and this video short, let's look at some prerequisites without going to much details on what we need even before we start making a schedule. First, from the scope area, you need the scope statement, which is whatever you will do and you will not do as part of this project. Then you will have the WBS, the work breakdown structure, the hierarchical breakdown of your work, of your entire scope, plus the WBS dictionary, which basically describes the entire work package or all the work packages. And then from this WBS, you create a list of activities, which basically are the executing pieces in the project. So you'll have a list of all the activities that you would need to deliver the work packages planned in the WBS, and also a list of all the attributes, basically like what is the duration of the project, who is the manager, who is the work package manager, the activities, responsible person, the start date, end date, estimate of the durations, of course, and most importantly, the sequence. What comes before, what comes next, what are the predecessors for any activity, what are the successors, and what are the dependencies. You have some dependencies like hard dependencies where you cannot break the dependency. That is the nature of the project itself. Discretionary dependencies or where the project manager takes a decision what to place first and what next based on certain situations in the project. And then you also have leads and lags, by how much time you will delay the successor activity. After a predecessor activity, it's a lag, and by how much time you will bring forward a successor activity is a lead. And then, of course, there is also the finish to start, start to start, finish to finish, and start to finish dependencies. All of this, the assumption is you know it, now that you've come to this point where you're developing the schedule. So once you have all these things, the WBS with the dictionary, the scope statement, the list of activities, the attributes, the sequence of the activities, and an estimate of the activity durations, you will enter into developing the schedule. Of course, some of you were asking what are the different techniques to estimate the duration of an activity. You can use a ballpark method, a rough order of estimate method, an analogous estimation method, a parametric estimation method, or the most famous one, the 3-point estimate or the PERT estimate. We will not see that in this session because the scope of this session is how to develop a schedule. The assumption is you already have all this information in hand when you start developing the schedule. One request, please have a pen and paper with you. If you don't have, please pause this video now, go get a pen and paper, and then restart the video. You'll be doing some calculations. I would recommend that you do this along with me so that you understand. We cannot simply watch this video and understand the concept. You have to work it out along with me. So it is more like a workshop. So now let's go to the next topic. How do we build the schedule? So what you're seeing on the screen, take a moment, pause this video, write it down on your pen and paper that you've just got. So this is the list of activities, the duration of each activity, and the sequence of the activities. We will use this as a case study for the rest of the video. So please take a moment, pause the video, take a screenshot of it, or you write it, even better, write it down exactly what you're seeing on the screen, this table on your pen and paper, so that you can refer to it often. So the meaning of this table is very simple. You start, and then the first activity in the project is A, which has a duration of 2 days. A is followed by its successors B and C. B follows A, which is its predecessor, and D and E come after it, which are its successors, and the duration of activity B is 5 days. Like that, say for example, D, duration is 1 day, it follows B, and is followed by end. So this is basically the sequence that you have actually built based on your project experience, the project requirements, the dependencies, and everything. And with this, they will start making the network diagram. I hope this is clear for you. So we already have a built network diagram. So what we will do is, this is the output. We will build exactly the same network diagram in this video. So as you saw here, the activities list is a list of all the activities. Predecessors come before each of the activity mentioned against it. Successors come after the activity mentioned. So activities B and D come after B because they are its successors. And A comes before B because A is its predecessor. So some techniques, that's why I wanted you to get a pen and paper. So how we draw, there are some basic ways how you can draw this. So always start here, start. What is the first activity? So A is the first activity. So before going into the network diagram, I will give you a tip how to draw this. Always draw a big box, and on top of the box, write the name of the activity A. In the middle of the box, write the duration of the activity, which is 2. And then you draw 4 little squares on each of the 4 corners of this box. I'll tell you why. Draw it big enough so that you can write some numbers, something like this. So this is how you draw. Since this is a video, a recorded video, which you can also pause, rewind, and forward, I would not repeat these things. So let's start by drawing A. Sorry. So the first activity is A. What is the duration of activity A? It's 2. And after A, you get what? B. And C follows A as well. Oh, sorry. Right on top. Then B is also followed by another successor, not just, okay, so B is followed by D. And after C, you have E. So, and D and E, they have end as the successor. So if you refer the table that you have on your piece of paper in front of you, we start here. After start, you get A. A has 2 successors, B and C. B has 1 successor, D. No, 2 successors, D and E. So this is what you're drawing. So B has 2 successors, D and E. Then C has 1 predecessor, A, 1 successor, E. D has 1 predecessor, B, and 1 predecessor successor, end. So E basically has 2 predecessors. You see B and then C, and 1 successor, which is end. So this is how we draw the network diagram. So very quickly, sorry. So now that we have drawn the activities, we have drawn the sequence of the activities, and we'll also list the durations of these activities: 5, 1, 1, 2. So we will draw on the 4 corners the 4 boxes that we saw earlier, or that we mentioned earlier. So please draw along with me these 4 boxes. I'm going to draw this a bit neatly. So I'll tell you why you need these boxes. So now that you have drawn this, we will do the first step, which is identifying all the paths here. Path basically is very simple. You start, you go to A, arrow mark, B, D, and D. This is one path. Second path, you start again, you go to A, you go to B, and then E, and then end. You can see the arrow marks. You just drew, because E is also a success for B, right? And in the third path, you start, you go to A, you go to C, E, and end. So there are 3 paths here, and we will now calculate the duration of these paths. Duration of the path is the sum of the durations of each of the activities on that path. In this case, the duration of this path A, B, D, and end is 2 plus 5 plus 1, which is 8. The duration of the path A, B, E, end is 2 plus 5 plus 2, which is 9. Duration of the third path A, C, E is 2 plus 1 plus 2, which is 5. So what is the longest duration path? A, B, E, and end, which has a duration of 9 days. So this is called the critical path. So I made this clear now. So the path A, B, E, and end, which has a duration of 9 days, is the critical path. It is not called critical because it's critical to you or to the customer or to your boss. It's critical because the activities on this path are critical for the project to be delivered on schedule. If any of the activities on the critical path are delayed, the entire project will be delayed. That's why it's called the critical path. Now, we will start certain activities on the critical path, and then we will do the same activities on the next longer path, and then to the next longer path, and so on and so forth. So we will do now what we call as a forward pass. So forward pass is when you make the calculations from the start to the end in this direction. You also have equivalently a backward pass where you start at the end and you go to the start. So this is basically the forward and backward passes. In the forward pass, you will calculate the early start and finish dates. You will see what they are. In the backward pass, you will see how we make the late start and late finish dates. So now we will write certain things near the boxes. Always you're going from left to right, right? Start to end. Always the start is on the left, the finish is at the right. Start is on the left, finish is on the right. Now early is always on the top, late is at the bottom. So early is on the top, late is at the bottom. So early start is top left, early finish is top right, late start is bottom left, late finish is bottom right. So you can write this. I'm going to write it only for one activity A. On your pen, on your paper, please write the same things outside the boxes but near the circles for all the other activities, something like this. For all the 4 activities, I'm not going to write for all the activities for the sake of time. So now we will start with the forward pass. So in the forward pass, you calculate the early dates, start and finish. So now the common sense is the first activity on the project cannot start earlier than the first day of the project. And you always assume the project starts on day 1. Some people will also use day 0, but commonly we use day 1 as the starting date of the project. So you write the early start of day activity A1 here. So activity A cannot start earlier than day 1. Now it's a 2-day activity. Always assume that whenever I say start, it means you are starting at the beginning of the day, which means you have the entire day as day 1 to finish the activity. So our 2-day activity that starts on day 1 will go through day 1 and then one more day, day 2. At the end of day 2, it gets over. So when I say end or finish, it finishes, the activity finishes at the end of day 2. So this is a thumb rule that I use for my understanding when I prepare for PMP. So when I say start, I mean it starts early morning of day 1 or the start date. When I say finish, it finishes late evening on the end date. Now, for the next activity, since you're finishing the previous activity the night of the previous day, the next activity cannot start before the morning of the day after. That means activity A finishes on day 2, that is at the end of day 2, and the next activity on the critical path B is the next activity. It can start the day after. So day 2 end is the finishing of activity A. So day 3 early morning, you will start activity 3. So some formula you will use, Rita or some other book will say, to calculate early finish, you use a formula early start plus duration minus 1. Very simple. Early start is 1 plus duration is 2 minus 1. So 1 plus 2 minus 1 again brings you 2. So 1 plus 2 minus 1 is 2. This minus 1 you use because sometimes we fail to count the actual day of starting. We assume an activity that starts on day 1 It takes 2 days. So 1, 2, so day 3. 1 plus 2 is 3 days. So day 3. No, actually day 1 is also to be counted. That's why you use this formula 1 minus 1. So now an activity that starts on day 3, 5 days means day 3, day 4, day 5, day 6, day 7. So on the 7th day, this activity will finish. Of course, if it's a small number, you can use this. If it's a big number, you cannot count them by hand. That's why you use the formula early finishes, early start plus duration minus 1. So similarly, the next activity on the critical path is E. So E will start the day after B finishes. So day 7 is when B finishes. So, oops. Yes, sorry. Yeah. So day 8 is when you will be able to start activity E, and then a 2-day activity starting on day 8 will finish on day 9, the end of day 9. So this is a forward pass. Now let's go to the next longer path, which is ABD. Now, when you are doing this tracing the forward or backward pass, if you come across an activity where you have already filled the details, you will not fill them again because they have already been filled, because those activities are already on another path which you have traced already, and that could be a critical path or a longer path than the current path. So you will not touch that. So A is the first activity you will not touch. It's already done. B is already done. D. So D, its predecessor B finishes on day 7. So 1 day later on day 8 it will start, and the 1-day activity starting on day 8 will also finish by the end of day 8. Now going to the third path, A, C, E. A is already filled. C, its predecessor A finishes on day 2. This starts on day 3, and a 1-day activity that starts on day 3 will also finish on the same day, end of the same day, 3. Now you do something called a backward pass. The backward pass, basically you start from the end and go to the front. So here you will calculate the late start and late finish details. So again, start with the critical path. What is the last activity on the critical path? A, B, E. E is the last activity. Use this formula. The late finish of the critical path's last activity will be the same as the early finish of this activity. Yeah, it's no wonder, right? This is how it has to be, because this is the last activity in the longest path in the project. So there cannot be any activity after this activity, and whatever you do has to be on a path that is the longest. That is the definition of the duration of the project or schedule of the project. So logically, this activity E is the very last thing you will do in the project. D is also there before end, but D is not on the critical path. So even D can happen a little later, but the project will not be delayed. But E, if E is delayed, the project will be delayed. That means the late finish of E should be the same as the early finish of E, which is 9. So the late finish and early finish for the last activity on the critical path will be the same. This is the starting point. Now that you have done this, you use a similar formula to calculate the late start. I'll write this here. You are going to finish an activity on day 9, which means at the end of day 9. It's a 2-day activity. A 2-day activity that finishes on day 9 must have started at the beginning of day 8. So early morning of day 8 it starts, full day 8, full day 9, it's 2 days, 2 full days, 2-day duration, you finish that. So similar to forward pass, you have a formula here. Late start is late finish minus duration plus 1. In this case, late finish is what? 9 days. 9th day minus duration is 2 days plus 1. So 9 minus 2 plus 1 is what? 8. This plus 1, like earlier in forward pass, minus 1 you had, right? So this plus 1 is to ensure you don't miss counting the finishing date. Otherwise, you say my activity finishes on day 9. It's a 2-day activity. So 8 and 7, you'll make a mistake. So when you say 9, day 9 it finishes late on day 9. So the entire day 9 is available to finish the task. That means a 2-day activity, one of the days is day 9 itself, and the previous day is the first day, which is day 8, which is the reason why you use this formula. You'll see this later also. For you take a screenshot, or you can, as this is a recorded video, you can rewind and take this. So now let's proceed. So if E is going to finish on day 8, its predecessor along the critical path B, it has to, or if E has to start by day 8, my mistake, sorry, late start, early morning of day 8, E has to start. When should its predecessor finish? One day before, right? So one day before day 8 is day 7. So by the end of day 7, B should have finished. Otherwise, the project will be delayed because it's the critical part. So day 7, by day 7, end of day B should have finished. Using the method earlier, a 5-day activity ending on day 7 is day 7, day 6, day 5, day 4, day 3, beginning of day 3. You must have started latest. So day 3 is the late start, latest by which activity B can start. And similarly, one day before its predecessor activity A should have finished, and it's a 2-day activity, so basically day 2 and day 1. So day 1 is the late start of activity A. So what is the meaning of early start and late start, or early finish and late finish? Early start and early finish means whatever you do, there is no way you can start earlier than the date or you can finish by the date. There are imposed constraints. Your hands are tied. Late start and late finish means you must finish hook or crook, whatever it is, you must finish by the date or you must start by the date. If you don't, the project will be delayed. It means it's like a gun to your head. Early start, early finish is like rope tying your hand. A late start and late finish are like a gun placed on your head. So you cannot start or finish earlier than that date. Whatever you do, that's early. You must finish by the late finish or you must start by the late start, else your project is in danger of finishing behind schedule. So this is how you calculate the late start, late finish using backward pass. Now critical path is done. Let's go for the other paths. The next longest path is A, B, and D. Sorry. So now let's calculate for, so A and B are already on the critical path. You have already calculated, so don't touch. So let's start with D anyway. So sorry, we anyway start with D. So now the critical thing is for non-critical paths, the late finish of the last activity on any non-critical path will be exactly the same as the late finish of the critical path's last activity. Why? Because the critical path is the longest duration path and the last activity on the critical path is the last thing, the latest date by which you will finish that activity. The latest date by which you finish the last activity of the critical path will be the last date of the project, in this case day 9. So you are allowed to finish any damn activity on the project, any other activity that comes before this last activity E on the critical path. You have the freedom to finish also by that same day, without delaying the project. So D is not on the critical path, but since E, the last activity on the critical path, which is the longest duration, finishes on day 9 only, you can also finish any other activity by day 9, still you will not delay the project. Which is why you will write the same last late finish date of E for D also. Now everything is simple. The 1-day activity starting on day 9 will finish on day 9, but then B and A backwards you will not fill them because you already filled them. Come for the last part, E, C, A from backwards. E is already filled. So C, early start for, sorry, late start for E is on day 8. 1 day before it, 1 day before the end of the previous date has to finish. So day 7, C has to finish. And since it's a 1-day activity, it also can start as late as the beginning of day 7. So that's it. So we have basically built what we call as a network diagram or the critical path method, using the critical path method or the PDM, Prerequisites diagramming method. It's also called activity on node because you see these activities A, B, C, D, E, they are at the head of the arrows, right? These are the nodes. There's another kind of method which is called activity on arrow, where you will write the activities on the arrows, but that is not the scope of this video, so we will not see that. So this is called activity on node, AON, activity on node, or critical path method, or network diagram, or precedence diagramming method. So these are related terms. So this is how you build. So now let us see some interpretations of this critical path, what we did. All this mathematics you can do if you have a formula. We don't need a project manager to do it. Even our kids can do it. So you are there as a project manager to make interpretations out of this and to take some actions out of this. So what interpretations will you do? First thing you see, the float of the critical path is always 0. The late finish and early finish is the same. Only for the activities on the critical path. That means you cannot in any ways finish an activity before day 7 for B, but you must also finish it by day 7. So you cannot start earlier than day 7, but you can also not finish later than day 7. There is a wriggle room, nothing. So the float of these activities on the critical path is 0. Another word for float is slack. What is float? Float is the duration by which you can delay any activity without delaying the overall project. Total float is the duration by which you can delay any one particular activity without delaying the overall project. Free float is the duration by which you can delay any activity without delaying the immediate successor activity. In this case, if you take C, E it's a successor activity, but E also happens to be on the critical path. So the total float and free float for activity C is the same. Take B. It's what is B's float? Basically, B is on a critical path. The float free or total float is 0. Imagine there was another activity here. For example, there is an F and then going to E. And this F is basically not on the critical path. Sorry, this F is hidden by the watermark here. So imagine after C, you have one more successor, F, which has E as its successor. C also has E as its successor. And F is not on the critical path. Then C will have a free float, which will ensure F is not delayed, even if you delay the activity by some days, and a total float by which the activity E on the critical path or the total project's duration is not delayed. So this is the meaning of a float. If you see for activity C, what is the float? It is basically float is late finish minus early finish or late start minus early start. These two values will be the same because starting, see, late start or early start and late finish and early finish, they're interrelated. So late finish minus early finish and late start minus early start will have the same value. And this is the number of days by which you can delay activity C. So in this case, if you see here, 7 minus 3, 4. So C has a float of 4. So C cannot finish absolutely nowhere on earth. It can finish before day 3 here. But it can finish on day 4. It can finish on day 5, on day 6, also on day 7. Because late finish is day 7. So 4 more days later, it can finish. Still, the project will not be delayed. So C has a float of 4. D, 9 minus 8, 1. D has a float of 1. D can finish on day 8. It cannot finish before day 8 because it's early finish. But late finish being 9, it can also finish on day 9. 1 day later, still the project will not be delayed. This is the interpretation of float and of all these values. As a project manager, your job is to ensure you give maximum attention to the critical path. Concentrate your resources, your experts, your major resources on the critical path, because if critical path, any activity is delayed, the overall project is delayed. So you can move some resources from non-critical activities like C and D to the critical activities like B or to A or anything. But ensure that you don't concentrate so much on the critical path that you bring some non-critical path activity on the critical path. So from from C and D, which are non-critical path activities, you can move resources to the critical path activities. That's perfectly okay. As long as you can bring or keep the critical path on track without delays and without bringing C and D into the critical path. So this is one action you can take with these values. And of course, last week you would have basically seen something called in earned value management. Let me go to the next screen where we have actually already a built network diagram for you, which is slightly neater. Hopefully, sorry. Oops. All right. I'm erasing this. Okay. So now in earned value management, you saw some things like SPI and CPI. Imagine a scenario where SPI is less than 1, CPI is greater than 1. It means your project is behind schedule and under budget. You have saved some money. So you can use that money to put in more resources to the critical path activities, so to bring the project back on schedule. So you have more money saved. That's why your CPI is greater than 1. You use that to bring in more resources, more concentration on the critical path where there is a delay, which is why SPI is less than 1. So that you bring SPI equal to or greater than 1. You are bringing the critical path activities back on schedule by using the money you saved. Or, where possible, move existing resources from non-critical path to critical path activities. So this is how you can basically interpret the values from the critical path. So now let us come to the closure of this session. I will summarize whatever we saw in this session, the steps to develop a schedule. First, you have all the prerequisites from scope and schedule, like WBS, scope statement, WBS dictionary, activity list, activity attributes, sequence of the activities, dependencies, everything, and the duration of the activities, estimates, and the basis of estimates. Now, first step is, after you draw the initial diagram from the table list of activities with the sequence, predecessor and successor, first step is you identify all the paths in the diagram. And then you calculate the duration of each path, which is the sum of the duration of the individual activities on the path. Then you find the longest duration, and that's the critical path. And then you do a forward pass followed by a backward pass. In forward pass, you always start with the first activity and assume it starts on day 1. Using the duration value, this formula, you can calculate the early finish of that activity, and so on and so forth, and all this for critical path. Once you're finished with this, go to the next longer path, and so on. And once you have done this, do a backward pass, but now start from the end, the last activity on the critical path, and then go to the last activity of each path, each other non-critical path, after you finish one backward pass on every path. Now, the last activity on the critical path being critical, the late finish and early finish activity dates will be the same. Using this, you do a backward pass calculating the late start using this formula here. Like that, you calculate all the way back to the start of the project. Then you go to the next longer path and you calculate starting from the last activity of each of the paths. Again, for each non-critical path, the late finish of the last activity will be the same date as the late finish of the critical path's last activity, for the reasons we mentioned earlier. So with this, you do a backward pass for each of the paths. Now, the +1 and -1 in the formula we saw here was to ensure in forward pass you take into account the starting date also, and in the backward pass the finishing date of the last activity also. And if when you are doing this forward and backward pass, you come to an activity where already you have filled some details, do not change it. Leave it untouched, because those activities are on some other path, which could be the critical path or a longer path, so do not touch. And finally, float and slack. Obviously, for a critical path, the float and slack of the whole path or of the individual activities on the critical path will be 0. And for all the paths, the float or slack is a duration by which you can delay an activity without delaying either the immediate successor activity or the overall duration of the project. So this is a summary. So with this, we come to an end of this session. We will meet again in session 3. I have a couple of requests. First, please like, comment, and share this video widely so more people can get benefited. This is free of cost, right? And subscribe to this channel so you get updates on future videos on this channel as I post them. Second request, please share via comments to this video or to other videos on this channel, or contact me directly on what topics you wish to be discussed in these sessions. I will take the topics for the weekly sessions. So please come forward with your suggestions for topics, and also share this video and subscribe to this channel widely so that people benefit out of it. So with that, I thank you all for your time. God bless, all the best, and look forward to seeing you in the next session. Thank you. Bye.